All right, so we're gonna go ahead and apply our identities. So up first, it says, given cosine theta equals 3/5 and sine theta is less than 0, meaning that sine theta is negative, find sine 2 theta, cosine 2 theta, and tan 2 theta for the given information. So the first thing we're gonna need to do is find out what our sine and our sine value is. Sine and tangent. Yeah, but you're gonna find the values first. So we know that cosine theta is 3/5, right? Because cosine theta is 3/5, the ratio is x over, why is it not x over r. I just want to be great sometimes. All right, let's try that. So it's x over r. So therefore, our y has to be what? 4, right? It's a 3, 4, 5 triangle. It's going to always be. If r is 5 and x is 3, then y has to be 4. So, and it's going to be a -4. Good job. Y is, then you would just do Pythagorean theorem. But 3, 4, 5 is an automatic Pythagorean theorem. 3 squared plus 4 squared equals 5 squared.
Okay, but if I did Pythagorean theorem, then it worked.
All right. So we have our cosine theta equals 3/5. Our sine theta equals -4/5. And our tan theta would equal.
It's cosine over sine.
So -4/3.
I was writing, where did you get 4 from?
Because it told us our cosine theta is 3/5. Okay, I can draw it out for you real quick. Okay, so we know that cosine theta is 3/5. We know that sine is negative. So that means that sine and cosine is positive. So that means our angle is in the 4th quadrant.
Oh, this is talking about
So this is 3, this is 5, so this has to be 4. I just didn't go back in time.
So that 4 in the quadrant.
Because your cosine is positive and your sine is negative, so that means that it resides in the 4th quadrant. All right, so now I have all these values. Can I find sine 2 theta? Yes, so sine 2 theta equals, what is the identity for sine 2 theta that you just wrote down?
Sine 2a cosine.
So sine 2a, so in this case, theta. Sorry. I already wrote the sine 2. Now I'm gonna write the cosine equals what?
Equals 2 sine theta cosine.
And do we know the value of sine and cosine? So we're going to plug those in. So sine theta equals -4/5. Cosine theta equals 3/5. We do the math. 2 times -4 is -8. -8 times 3 is -24. 5 times 5 is 25. I just multiplied. That's it. Do anything else?
So for the sine theta, was
So what you do
-4
with
sine?
Oh, okay.
The what?
So we're gonna have to like draw a triangle.
You don't know. She just asked me how did I know y was 4, and I drew it out to show why. By now, at this point, they're assuming you're able to do this without drawing. If you need to draw the triangle every time or in the coordinate, then that's just up to you. That's part of your work. Yeah.
Okay,
For-
I see. For -2 times 4.
You remember, if it's a whole number, it only multiplies to the numerator. 2 times -4 is -8. -8 times 3 is
Okay, that's
-24. Denominator times denominator is 25. All I did was multiply.
I was just trying to make sure that you did when you got the -4 times 2,
Mhm.
that you multiplied the 3.
Yes, yes. When you have a whole number, it's only times the numerator. All right. So do we see how using identity works? Once you have all of your key players, all it is just substitution. And so you're gonna do that for the other one. So you're gonna do the same thing. I'm gonna, you pick whichever one you want. So now you're gonna go do cosine 2 theta and you choose which of the 3 identities you want to use is gonna come out to be the same. I'm gonna let you guys do cosine 2 theta. And then let you do tan 2 theta. And then we'll check back. While you're working, let me know if I can.
You get that 4 to the quadrant, right?
So you got 4 because Pythagorean theorem. If I have 3 and 5, what does this have to be?
Oh. So X. Oh. X.
Yeah, x squared plus y squared equals r squared, right? So all I did was Pythagorean theorem. But we've done 3, 4, 5 Pythagorean theorem over and over that I should by now know that this is always going to be 4. Okay. All right. Cosine 2 theta. What was your numbers you plugged in? Did we do the cosine squared minus 1?
5 squared.
There we go. So it's, let's see, I'll go backwards. Did anyone do anything else besides this one? Because this is the one that I would have done.
Yeah.
Did everyone do that one? Okay, good. Y'all are so smart. So we did 2 times 3 fifths squared minus 1. We did the math and we ended up with perfect. Okay. Tangent. So tangent 2 theta, what were the values that you substituted in? So we end up with -4 over 3. So 2. So we have 2 -4 over 3, and then 1 minus tan squared, right? And you have 1 minus -4 thirds squared. So notice how I'm protecting my fractions, right? With their parentheses. Doing the math. So we end up with -8 thirds over 1 minus 16 ninths. Yeah. And you kept going and going and going. And what did you end up with? 24 over 7.
Oh, we didn't need to do all the work. We could have just looked at the other two and gotten it from there.
That's what I was thinking, but the denominator for that one was different.
What do you mean?
Because if cosine is the x,
But the
and that's the y.
There you go. Then your other option is sine over cosine. There you go. You already had sine and cosine, so you could just do it with these two. Divide them. And you would still end up with 24 over 7. Is it okay that you use the double angle rule? It is. It's totally fine. But you still also have your other identities. Quotient identity still applies because the angles are the same.
So, for all of them, could you just like find your sine and cosine and automatically do those things?
Mhm.
Okay, so say it was like a different equation, could you find like tan and sine and automatically do cosine?
Yeah, because remember that's your, the 2 in front of the theta has already been applied because that identity was created. Yes, the 2 in front of the theta has already been applied. All right. But using the identity, was it terrible?
Yes.
Oh my gosh, whatever.
It just comes to that wide.
For you to come to the conclusion that there's,
But.
did you come to a conclusion? That means you understand the quotient rule and you understand the relationship between sine, cosine, and tangent. It was not. You plugged in the number and you typed it in the calculator. I watched you. So what did you do? I was like, what do you mean it was a lot of work? All right. So like you said, alternatively, you could have found tan by just simply already knowing sine and cosine.
You had me on the next slide.
Yes, it was coming. It was coming. I just wanted us to get to it on our own. And did y'all? Yes. Bam. Learning in effect.
They probably do another sign in the protractor.
Well, I kept these notes pretty straightforward, so. So here we go. So first off, you're going to find your values. But this time we have cosine double angle equals 4/5. It's a little bit different because it's not a single theta, it's a double theta. So our other rules of x over r do not apply. Does that make sense? Those rules do not apply because it's a double angle. It's not a single, it's a double, okay? What we do know is that this angle lies between 90 and 180. So if it's between 90 and 180, that's in quadrant 2. So we're using quadrant number 2, which means that our x's are negative and our y's are positive. So cosine is negative, sine is positive, and so yes.
What?
If we have negative x's, that means cosine is negative and sine is positive, and therefore tangent. Because it's a double angle, it's not a single. The double up. So if let's say, for example, double angle means, let's say we're talking about 120, right? What's double 120? But does that make sense?
Yeah.
Okay.
I mean, like, I know we stuff sign for it. Like,
You just needed to hear it out loud to double the angle. Yeah. All right. So now, what is the easiest function for cosine 2 theta is it for us to work with? The second one, right? I would say what is it? 2 cosine squared minus 1. That's the easiest one. So we're saying if we take this and we know what it equals 4/5. Can I solve for cosine? That's our goal, is to get cosine by itself. So this is where we use u substitution, okay? So we're gonna let cosine theta equal u. And what that looks like is now we have 2 u squared minus 1 equals 45. Do you know how to solve that? Yeah.
45 or
4 over
4 or 5.
Okay.
My line isn't making it. 4/5.
So we're substituting theta with you.
So we're substituting cosine theta with u. Can we solve that?
Yeah.
What are the steps I would take to get u by itself? Not subtract, but we're gonna. So we're using u substitution. Oh, she's really not talking. Okay, got it. Here we go. Plus 1, right?
I'm not. What are you talking about?
And what's 4/5 plus 1? So 5 over 5 makes 9/5. And then what am I going to do? Divide by 2, which is the same thing as multiplying by 1/2. And that gives me what?
9/10.
9/10.
It's divided by 1.5.
Divided by 2 is the same thing as multiplying by 1/2. And then what's the last thing to get u by itself? You're going to take the square root. So we get u equals 3 over square root of 10, which equals what? And what does u equal?
That.
U is our cosine theta.
I told them.
I'm sorry. Okay? Someone stole my pointer. How rude. All right, so we used our cosine double angle rule, right? So we have our rule. Are we good there? We know that the double angle equals 4 over 5. Yes. So we set it equal to 4/5. We use u substitution to replace cosine theta with U. So where cosine theta was, we put in a U, and now this just becomes this algebra problem, right? Inverse operations. Our goal is to get U by itself. So to get U by itself, the first thing America told us to do was to add the 1. So we added 1 to the other side. 4/5 plus 1 is 9/5, right? 5/5. 1 is 5/5. So we get 9/5. Now we're down to 2U squared. How do I get rid of the 2? Divide by 2. Divided by 2 is the same thing as multiplying by 1/2. And the only reason why I did that is because this is already a fraction, right? So I multiply by 1/2. Numerator times numerator makes it 9. Denominator times denominator makes it 10. So we were left with U squared equals 9/10. Now I need to get U by itself. How can I get U by itself? Square root. We take the square root of the numerator and the square root of the denominator, which is how we end up with 3 over the square root of 10. So our cosine value is 3 square root of 10 over 10.
Just a lot of work.
Yes, but the math is not,
No, it's not hard.
it's not hard, but the math, it's a lot of math at once. Okay, all right.
Can we always substitute cosine theta for U?
You could always use U substitution when you're using algebra. It takes the trig away for a little bit and allows you just to focus on algebra. Okay, if you ever take calculus, you also use U substitution in calculus. All right, so with that being said, it wants to find all 6 trig. Well, we found 1. We have how more to go? Okay, it's not that bad because right here, remember this guy? This 3 square root of 10? This is already telling us our x and our r. Because cosine is what? X over r. And so what do I need to do to find my y? X squared plus y squared equals r squared. So we have 3 squared plus y squared equals square root of 10 squared. That gives me 9 plus y squared equals 10. So y squared equals what?
So, next thing.
1. So therefore y equals 1. So now we have our y value. I can find sine, I can find tangent, and then I can find everyone's reciprocal. Do we see that? So let's make sure we're all good. So we know x equals 3, y equals 1, and r equals the square root of 10. So now we're going to brush off our ratios. Are we ready? So sine theta equals y over r. So what is our sign for this problem? Which equals? Perfect. Good job. Okay, now tan theta equals y over x. What is our y? What is our y?
Sorry, 1.
And what is our x? Are we done? Yes. Now we're on to secant and cosecant, right? So secant theta, secant is a reciprocal of cosine, so r over x, which gives us square root of 10 over 3. Perfect. And we have cosecant theta, which equals r over y. Perfect. And then we have cotangent theta, which is x over, which is just 3. The hard part again is getting the puzzle pieces. Does that make sense? Once you have all your pieces, you're just now using your knowledge. So now we have all 6 of our trig values. Okay, so we've taken a little piece from every section in this one problem. One of my,
Practice that 9 to be a 1.
yep, Because we had to get y by itself. All right. Go for it. No, you're good. Any questions though about anything that's written up here? No? Okay. Oh, I forgot to point out what's negative and what's positive. I knew I was forgetting a step. If I'm in quadrant 2, so everything is negative except what? Sine and cosecant. So I got to put my negatives. You're negative. You're negative. You're negative. You're negative.
But cosine is also negative.
The only thing in quadrant 2 that's positive is sine and cosecant. We have sea lunch, whatever time sea lunch is. Sure.
Yeah, well,
All right. I have that on my reminder on my next page. Remember that we gotta point out our negatives. Cool? So in a picture wise, this is what it would look like. So if I was in this quadrant, I would in quadrant 2, and we have our x is -3, our y is 1, our radius is square root of 10. Yes, if we were to draw it out, do you have to draw it out every time? No, it's just a tool if you need to see it visually. Cool? All right. Here we go. It says, verify that cotangent x sine 2x equals 1 plus cosine 2x. So you have to decide which side is your harder side. We're going to go ahead and go, for the sake of our notes, we're going to do the left side, and we're going to prove that the left side can become the right side. We all decided that we didn't want to do option 2, where we make them both equal to the same thing, right? Okay, cool. So up first, if I have cotangent x sine 2x, we want to get everything in terms of sine and cosine. Remember that? So step 1 for proving identities is to get things in terms of sine and cosine. So cotangent, using the quotient identity, becomes cosine over sine. Are we go with our first step? Our second step is to see what identities can we apply. Well, because of this 2x, what identity can be applied? The double angle of sine, right? We can apply our double sine identity now. So we're going to apply the double sine identity, which means I would rewrite it as 2x times cosine x. After you have put everything in terms of sine and cosine, after you have applied your identities, your third step is to simplify. So our third step is going to be to simplify. Now remember, this is over 1, right? So when you have a whole, it's over 1. And what's going to happen to our sign? They're going to cancel out because we'll have a sign in the numerator and a sign in the denominator. Do we see that? Okay. So sign goes away. And cosine times cosine is cosine squared. Yes.
so this is, it's 2 sine, and then 1 sine.
The 2 is its own factor. Yeah, the sign is its multiplication, not addition. So everything can be standing alone. Yeah. Everything is a factor, not an additive. Okay, so then when I look at cosine x, cosine squared x, 2 cosine squared x is equal to 1 plus cosine 2x. The double angle. Cosine 2x is 2 cosine x minus 1. And if I was to get it by itself, it becomes 2 cosine squared x equals 1 plus cosine 2x. So rearranging the double angle identity. And now I prove that this is how this guy becomes this guy. Because remember, identities can be rearranged to fit your information.
Yes.
Okay, let me go back to the double angle identity. I don't mind going backwards. So right here, we have 2 cosine squared a minus 1. But if I want to get cosine 2 cosine squared a minus 1 by itself, I would have to add it to the other side, right? And that's why it would end up being substituted. I can also, and when I substitute it in, it's going to be added to the other side, which makes it equal to cosine 2a plus 1 equals that guy. You can rearrange the identities to fit your situation. So that's why at the bottom I wrote, I'm going to start here with cosine 2x equals 2 cosine squared x. But I need to get cosine squared by itself. And when I get it by itself, it equals 1 plus cosine 2x. They're all literally their own puzzle pieces that can be moved around to fit your picture. Okay, but our steps again for verify. 1, we want to put everything in terms of sine and cosine. 2, apply any identity that you see. 3, you then want to simplify, which means to get rid of parentheses, combine like terms, eliminate where it needs to be eliminated. And then 4, again, is to check for identities that will make your other side equal. Okay, so you go through those same 4 steps every single time that you're trying to prove identities. Huh? Good. All right, now we're gonna talk about simplifying expressions. So here we have cosine squared 7x minus sine squared 7x. Now, thinking about our identities, does this look like any identity? The identity that we're talking about here is that our theta, or our angle, however you want to look at it, theta equals 7x. So this could be written as cosine squared theta minus sine squared theta. That's if they're being added. In order to equal 1, they got to be added together. But
Isn't that
minus,
The first double angle.
it's the first double angle. Good job. You would use your double angle identity. It's the cosine double angle identity, which means that I can condense cosine squared 7x minus sine squared 7x down to cosine 2 sine x, which becomes what? 2 times 7 is 14. So it becomes cosine of 14x. So that would be my simplified form. Okay, on B, this time our theta is 15. So we're thinking about any identity that says sine of theta times cosine of theta. It would still be which one? It would be which double angle? The sine one, right? So it would be your sine one, but manipulated. Do we see that? So it's the sine one, but multiplied by 1 because we don't have a 2. So we would have to manipulate it to fit our situation. So we need to make this. In order to make these equal, what do we have to do to the 2? We would have to cut it in half. So we multiply to manipulate. Yes.
Back to A and walk through all the steps again and do B.
Oh,
Thank you.
we have extra time today. And so notice here, it's normally 2 sine theta times cosine theta is your double angle for sine, right? However, I don't need the 2. I need it to equal to a 1. So how can I make it equal to 1? I do that by multiplying by a half. And when I multiply by a half, it's now going to be equal to 1. So now I can follow this rule. And this rule says that if I have 2 sine 15 times cosine of 15, I can substitute it down to sine 2a, sine 2a. And what is 2 times 15? 30. So now we're at 1/2 sine of 30. What is the sine of 30? Sine of 30 units are 1/2. Sine of 30 is 1/2. And 1/2 times 1/2 equals 1/4. Mine is, I was gonna help you with the unit circle. Because sine of 30 is 1/2. We actually know the value of sine of 30. If you go to 30,
Oh, yeah.
Mhm.
Why does it cosine?
I'm sorry,
Cosine's-
the cosine is gone because we went to our identity. So if I'm in the format of 2 sine A cosine A, I can condense down to sine of 2A. If having the 15 bothers you the entire time, you can always just use A all the way through and then substitute that 15 back in.
So for any of the sign like that, that equation thing,
Mhm.
I can always use 1/2.
If you need to get it down to 1. If it had been like going the other way, let's say I had a 4 here. So if I had a 4 on the outside, I need to get it down to 2, right? So that 1/2 would have made it go down to 2 because the formula requires that your coefficient is 2.
Oh,
Like the coefficient for the rule is 2. So your goal is to do whatever you need to do to match your coefficient. Does that make sense? You're just manipulating the piece. All right, and then, so our final answer is 1/4. And then Andrew, going back to the first one, we are looking for which identity has cosine squared theta minus sine squared theta. And like Asesha said, it was the first cosine double angle. So we use the first cosine double angle, which says that if I'm in this format, I can condense down to that.
Okay.
So we were in that format, so we condensed down to cos 2 sine x, 7x. And then 2 times 7 made it 14.
That makes sense.
Yep. The goal of simplifying is to use as least amount of characters as possible, right? We try to go from big to small, and the smallest you can go. Okay, with identities, you're either condensing or you are expanding. All right, cool. Okay. Here, so it says write sine 3x in terms of sine x. Now, do we have a rule for triple angle? No, there isn't a triple angle. So what we're gonna do is we're not gonna focus on the triple angle side. We're gonna focus on the sine 2x plus x side. It all builds on top of each other.
yeah.
Yep.
I was like,
Mhm.
I learned this.
Yep. So we're gonna transform this into that.
So then we're,
So we're gonna do our sum identity of sine. When you have 2 angles being added, you can expand them, correct? Do you remember that's from last 5.4?
I didn't. What'd you say?
Sum and difference, was that 5.4 or 5.3?
That was like,
Yeah.
yeah, 5.4.
Sum and difference was 5.4, yeah. So we're gonna expand it. So you have your angle A, your angle B. Remember, it was sine of A times cosine of B plus cosine of A times sine of B.
Where did you learn that equation from? Or we're learning that equation now?
We did it in 5.4. It was one of our sine sum and difference identity.
Oh, so we're just subbing that too, or?
We're expanding. So we're trying to expand to see if we can turn it into sine 3x.
Did you do it 3 times?
We're gonna keep going. Now I have a double angle, right? So we already used the sine and sum. Now we are going to expand on our double angles. So we're gonna expand on the double angles. Sometimes you gotta make it big to cut it down. But do you see why I'm gonna use double angles now? You have cosine 2x and sine 2x. So when we plug in our double angle identities, for sine, we substitute in 2 sine x cosine x. For cosine 2x, we substitute in cosine squared x minus sine squared x. Now, there are no more identities that can be applied. So we did, everything's already in terms of sine and cosine, right? We now have applied all the identities that we can apply. Now we're going to the third step. Simplify. Okay, now we're going to simplify. So what's the first step of simplifying? Getting rid of the parentheses. So in order to get rid of the parentheses, we have to distribute. So I'm going to distribute cosine into this, and then you get a sine, you get a sine. So we're going to distribute. Yes.
Oh, 'cause it's all one term.
It's all one term, exactly. So it only goes in one time. That's why I drew one arrow to emphasize. So 2 sine x times cosine makes cosine squared. Then we have cosine squared x minus sine squared x, and we distribute sine x. So we get cosine squared x times sine x minus sine cubed x. Okay, so at this point, you're like, I still don't know how it's going to get down to that little bitty sine 3x. Any suggestions on how I can get this down to sine 3x? Oh. Skip some stuff. So now, note, remembering that cosine, it's not combining like terms, it's you're going to apply your Pythagorean identity. Pythagorean identity, remember, is sine squared theta plus cosine squared theta equals 1. Do you remember that? So from Pythagorean identity, that means that cosine squared theta equals 1 minus sine squared theta, or sine squared theta equals 1 minus cosine squared theta. Every Pythagorean identity has 2 more identities that can be created from it, or in multiple identities can be created. But isolating the variables are the main one. The trigs, I'm sorry, not variables. So everywhere there's a cosine squared theta, I can plug it in, make it into what? Sine, because my goal is to get only to sine. So that means I need to get rid of the cosine. So how can I get rid of cosine? Everywhere there's cosine squared theta, it's going to become 1 minus sine squared. Everywhere there's cosine squared, it becomes 1 minus sine squared. And now my thing is fully in terms of sine. Then you clean it up. So now you're going to distribute, combine like terms. And after you distribute and combine like terms, it's now completely in terms of sine. Yes. So in conclusion, sine 3x, its rule would be that.
That was not gettable at all. I gave up.
Tell me where.
All of it. I don't think you have to explain. I thought it was Friday. It's tomorrow.
It's Friday.
Woo!
You were saying Thursday.
Wait.
It's Friday. Friday is review. I mean, Thursday's review. That's why I said you guys are have to be okay taking a test on a Friday because we've been gypped today. Does that make sense? This part? So it becomes 2 sine x, which times 1 is 2 sine x. 2 sine x times sine squared x becomes 2 sine cubed x, right? Now we're on the other side. This one, you're gonna have to do FOIL. I just didn't have enough room to write out the whole FOIL. So you have to do this times this, which is either doing FOIL or the box. I can model it with the box because I have enough room to do that.
When foil,
Right here, you have to FOIL in order. FOIL just means double distribution, right? That's all FOIL means. It's just a little cute way of saying do a bunch of distribution. And the reason why you have to FOIL, oh, never mind. You do not have to FOIL. I lied. Thank you, Andrew, for questioning me in my brain. You saw nothing ever. Your teacher was tripping. You just have to distribute your sign.
See, there's too much, that's why you get confused.
I know. I was like, where am I at? You just have to distribute your sign. So sine x times 1 is sine x. Sine x times sine squared is sine cubed. And then this was already here. And then now you're just combining. I have 2 sine x and 1 sine x. They make 3 sine x. I have -2 sine cubed, -1 sine cubed, and another -1 sine cubed, which makes -2 minus 1 minus 1 makes it -4. It does. I don't think I gave you anything this long.
Like, I see how you like.
I was like, I'm not gonna put this on a note.
Just be on the note card.
I see the idea.
What do you mean?
I
Why
do.
would I put this on the note card? Why wouldn't I?
Because you should just have the identities, not the problems with the identities, because it can be infinite. But there's infinite ways to use the identity. So it's probably just best on your note card to write down your.
Wait, are we done with this?
No, we have another set of identities to learn.
Another set,
Like, not like done.
Oh, this problem's done.
No, I mean like, we have another example left.
We have another set of identities.
So we're gonna do another equation just like this.
No, we have another identities to learn. Yes,
Oh,
Can you-
5.5,
can you-
6, right?
we're still in 5.5. We're still in 5.5. We can do 5.6 tomorrow. If y'all are gonna want to be tapped out. The plan was for tomorrow to be a review day.
Can you do this part into this again?
Yes. So this part, I'll highlight. How about that?
Yes.
All right, so highlighting. At this point, all you're doing is combining like terms. So you're looking for all your single signs. Where are all my single signs? I have 2 sign here and I have 1 sign here. So they combine to make 3 sign.
Okay.
Now I'm looking for all of my sine cubes. I have -2 sine cubed here, -1 sine cubed here, and -1 sine cubed here.
Okay.
And they make -4 sine cubed.
Thank you.
You're welcome.
Say that there was, you did that math, right?
Uh-huh.
Did I just assume, you have to double that too? And then before.
I don't know why you would assume that, but sure. Well, I'm not sure why you would assume that. See, I was a nice teacher. My teacher just gave us this problem and said, figure it out. And she gave us 10 minutes to process.
Me and her would have to throw me
Why?
everything.
Why?
What do you mean,
I
figure it out?
appreciate discovery learning. I feel like that's what made me more willing to, yeah.
I don't have any more room on these 2
I
pages.
think discovery.
Then turn the
learning is
page,
good.
Andrew.
But then I,
Then
No.
turn the page.
because then I have to do something weird with 5.6. Where I can't have it side by side.
Oh my gosh. All right, well, you're gonna have to turn the page because you have another set of identities to write. All right, so now we're on our product to sum identities. We're not, y'all don't care about the proof, I know. So we're just gonna jump to the identities.
So is this still 5.5?
I said 5.5 is long.
It's still 5.
Yes,
No,
yes.
that's fine. I can use another set of paper. I'm here.
Oh, you have more paper in your notebook? That's so cool. All right, product to sum identities. They go back and forth. So either you're condensing or you are expanding, depending on the situation.
Wait, Miss Jones, you wanted to do all of this 5.5.
That's what I was supposed to. I was gonna have to.
This is not gonna fit 45 minutes.
Well, no, we would have had yesterday and today. if it was a regular schedule. So you would have did. That was my plan. 5.6 goes a little faster. It's 5.5. We got to get over the hurdle.
Please don't put 5.5 on the
Really?
test.
Just skip the whole section.
Yeah.
Just one question.
All right, so if you look up here, what it is that, you know how we just did that whole long expansion? Well, someone already did that for these 4 identities, right? They've already did the expansion, they've already created the identity, and it says now, anytime you have the cosine of an angle times the cosine of another angle, this is how you would evaluate it. Does that make sense? If you have sine of an angle, sine of angle A times sine of angle B, this is how you evaluate it. This is also useful when you need to expand.
I didn't do 5.1.
Well, you have until Friday to get your life together.
Well, on this part I am, the other one, the double angle, I'm okay with that, but this,
You just started it.
I'm looking at it.
It's like we just started it. All you're doing is writing down the identity.
I'm
I just
looking
think
at
that's
this
too.
one.
Yeah.
So like when you're like doing an equation on the test, you wanna know which one.
You have to, that's part of knowing which piece of the puzzle to use.
I'm
So
putting
they
them in-
want us to
I'm putting
fail.
on every identity that we learned, 'cause I'm putting all of it on.
That's a good idea.
You probably won't even put this one in.
Will we be able to use our unit circle, like paper, or would we have to do it by hand?
It was by hand on there again. I was supposed to have it memorized.
Why are you like this?
But if we have to do
This the
this
first part of your
and
test
that-
actually is your unit circle.
Oh,
We have to do another unit circle?
It's the first part of your test. The first part of your test is your unit circle.
So-
I told you guys have to know
well,
the
I gotta
circle.
restudy it.
What's that clock?
It's down because some people got into argument over it. It's down.
I don't think it's funny because like, no, this is not a whole thing about it.
America said, "Where's that clock?"
I didn't know it was there the first time, but I forgot everything.
I did. You knew it was there? Yeah, I knew it was there. I just been saying. it.
I forgot about it.
Yeah,
'Cause it's
I
up
saw
there all
people-
year.
I saw people looking up, and I was like, where are they?
I forgot about it because
I
it's
was
just
doing
there.
it, so nobody could see. You were like this? No, I was over there.
She stood over there.
Yeah, so
She-
well, like, I know your glasses, but that's. The clock is pretty big. I
All
guess
right.
we need to see it again.
Oh, not yet, not yet. Okay.
There's some.
I know. I ended up like in high school, I made a ring of all the identities. So like I had a ring of all my note cards and every identity was written on a note card.
And we only get one.
Huh? No, that's how I studied because my teacher didn't even give us a note card. We had to just know most of them.
Me and my teacher was in throwing me.
It was- That's-
Every day I walk.
Her name was Miss Jones, oddly enough.
Have like a person study like that. Or
It's
like-
called studying, like
No,
you.
or like, so,
Need to apply them now? All right, so up first, we have, it wants us to write 4 cosine 75 degrees, sine 25 degrees as a sum or difference of 2 functions. Okay, so first we're gonna recognize that it's cosine and sine, right? So it's cosine and sine. Yes. You're writing this.
yeah, yeah.
Let me know when y'all are ready. Okay, so we're recognizing the fact that I have a cosine times a sine. So when I come and look at my product of sum identities, I'm not going to use the first one, not going to use the second one. I'm going to use the fourth one. It says cosine A times sine B. Do we see that? So that's the rule that we're going to be using, but we're going to need to change the rule. Why do I need to change the rule? There's a 4 in the front now. So we're going to be using cosine of A times cosine of B is going to equal 1/2 So we're gonna substitute our values in a minute. Minus sine of A minus B. Okay, but we need to make it equal to, we need this side to be 4. If this side becomes 4, what do I have to multiply this side by in order to make it 4? Yeah, what do I have to multiply 1/2 by in order to make it a 4? 8. So we have to multiply this all by 8, otherwise it won't be a 4. Does that make sense?
Probably.
So we have to multiply this side by 8. Yes?
Why
Sorry.
is it cosine A equals 20?
I didn't write that. Some other person did that. You never saw anything. It's just a glitch in the system. Yep. Okay. All right. So now, are these identities the same? Yes, because they both have the same, it's balanced. Does that make sense? All right. Yes.
What do we get that? You, multiply those to get 4, like that would equal 4, cause you have to. Right.
No, I made up something there. You just got to multiply by 4.
It's, oh.
I lied. It should be a 4. It should be a 4. Because what I do to one side, I do to the other.
You can still put 8 though, right?
No,
8 times 1
it would just be 2. It was me, my brain. What you do to one side, you do to the other. Just remember that. That's it. I made it harder than what it was.
But.
I blame it on me. Blame it on me.
4 times.
All right. Do we know what A is? Yeah, I just needed to change that side to be a 4, and therefore I can change the other side. We don't have to make it equal to 4. We just have to, what you do to one side, you do to the other. That's it. Yeah.
Okay, so last one, we were trying to make it 2 though, right?
Yeah, that's why we had to
Why
divide
is
it.
it different?
Because I was showing you the other way of doing it instead of manipulating the other
So
side.
this is a whole different way to do it?
Yes, well, not a whole different, but easier. So now they're exactly the same. All right, do we know what A and B are? So we're gonna plug everything in. 4 times 1/2 is 2. So we have sine of 75 plus 25 minus sine of 75 minus 25. And we keep going. And we get 2 times the sine of 100 minus the sine of 50. And if it doesn't ask for an exact value or anything, and this is where you stop.
You don't.
Can't go no further. Is it not being expressed as a sum or difference? It is. It's being expressed as a difference. So if I knew that, if I had plugged it in, sine of 100 minus sine of 50, double it, and that would be the value of that.
Thank you.
Okay? Are we good with the quick manipulation of the formula?
Yeah.
All right. Next.
No,
Wait, wait,
no.
Are you so?
No.
No.
There's more?
Oh, goodness.
So this is just the inverse of that.
No, it's completely different. These are sum to product. You just wrote down product to sum. It's too late.
Real life one.
I'll let you make a whole sheet for the test. Is that our compromise?
Yes,
You have a 1-pager.
thank you.
I'll give you a 1-pager. That's a lot.
Yeah.
That's a lot.
This is a lot.
That's a lot.
These are big equations.
Fine.
This over,
Compromise made.
only over 5, unit 5.
Yeah, we haven't gotten to 5, 6 yet.
But we get a front and back sheet, so.
No. No. I gave up. This ain't no way.
This is the last set for 5-5. This is the last set for 5-5. This is the last set for 5-5. That last one wasn't even that bad, guys.
Yes, it was.
Oh my god.
It's just like on the test, you can figure out which one.
Yes.
Out of the 50.
She smashed the next page.
Yeah, why would I?
Then you write little, that's fine.
So again, you know, if it makes, I will sacrifice the front and back one page.
There's no way you thought we was gonna fit all this on a note. Like,
I figured you would just know the rest.
No,
You only put the stuff you absolutely don't know on.
all of it.
I put enough, so I want like, oh. I got
This
this
is
on
on
paper,
paper,
right?
right? Yes, our test is on.
And there's how many parts? Like, no.
The only,
You put part-
there's the non-calculator with the unit circle, and I think it's like 5 non-calculator problems. And then the remaining 10 are calculator, but you really don't need a calculator for identities, it's all manipulation.
I'm gonna
Yeah.
that calculator. Definition.
Okay. Me too.
But if they think so, I don't trust my math. I don't know, I'm gonna just trust myself. Wing it.
And we only have
I'm
one
tired.
example left after this.
I'm tired
For
of
five
my.
more
I can't wing nothing else.
If I'm good, I'm good.
So you're just gonna watch Bob's Order?
Yeah. It's helping me out.
Okay. It's obviously funny to her.
So I couldn't continue. All right, yeah, that.
All right, so sum product identities. It means that you're taking addition and subtraction situations and you're turning it to only multiplying of the trig. So instead of adding, you're now multiplying. Okay. What time does 6 period until? Regular 2:25? So you gotta be in 8 period at 2:30. All right, now in, all you have to do is decide which one of these you're using and then plug in.
Okay.
Okay.
Why are all of them regular, like 2 sine, 2 cos? Why is the last one -2?
30
Oh,
off
I
the
didn't
day.
even see that.
And it's all time.
Is that correct? though?
Yes.
You never know.
You never know. You're right. I've never claimed to be perfect.
You be throwing me for a look sometimes.
Me
you know.
too.
I be,
The thing is that I actually practiced talking to myself teaching the lessons before. Oh, so then it's always like, what were you thinking? That's not what you said earlier to yourself. Maybe it's the talking to myself part that just.
let's try.
All right, here we go.
Oh,
All right, so we have sine 2 theta minus sine 4 theta. Which rule are we using?
So 2 times, so the second one.
The second one.
Okay.
Okay, so for the second one, our A equals 2 theta and our B equals. And do we have to do any manipulation? No, because it's already saying. I haven't did anything.
Oh.
I haven't did anything.
I'll put that second.
Okay. No. We don't start fighting theta until the next unit.
With
And
only,
chapter,
like, only this information.
that's it.
Theta,
Next unit?
theta is just like a
And-
variable.
In theta is an angle measurement. In chapter 6, we start actually solving for theta. We're not yet there, so it's okay.
How long we got until the end of April?
The next 3 chapters go really fast. All right,
Okay, so once you find the fraction, you subtract those two?
you just,
Wait, so when the final
You going
comes,
too bad to
do we
wait.
have to
I
like
just
delete
wanna make
all
sure I
of
got
these
this,
identities,
'cause
like the ones we've done over the whole year?
I think it's 4.
okay, so we determined that for sine 2 theta, sine 4 theta, we were gonna be using the second one, agree? So we plugged in, we started plugging in, wherever my pin is, I don't know where it's at. Oh, there it is. 2 cosine. Our A is 2 theta. Our B is 4 theta divided by 2 times sine. A is 2 theta minus B, which is 4 theta divided by 2. We clean this up. We get 2 cosine, and we have 6 theta divided by 2 times sine of negative 2 theta divided by 2. We keep cleaning it up, and we get 2 cosine 3 theta times sine of negative theta.
Okay,
Co-
yeah, it was -1, right?
negative 1.
Okay. I
So
got
when
it.
you get down to the negative, this is a cofunction, meaning that if I have sine of a negative angle, that negative can be moved to the outside. So it becomes -2 cosine 3 theta times sine theta. I don't know why I put my. Mhm.
Guys.
All right, that is the end of 5.5.
Thank God.
Hallelujah.